The maximum tension in the string of an oscillating pendulum is double of the minimum tension. Find the angular amplitude. Pendulum bob is suspended through L length string, and this moves like this. Maximum angular displacement, suppose this is theta. This point is O and this point is A, and extreme point suppose B. A per velocity is V and B per velocity is 0. Maximum tension will be at A. A पर जो बॉब है उसका वेट डाउनवर्ड एक्ट करेगा mg, and due to revolution centrifugal force will act downward. इसकी वैल्यू होगी mv square by L. This will equal to T1, and T1 is equal to mg plus mv square by L, and this will be the maximum tension. Minimum tension will be at extreme point B. Bob का weight will act vertically downward mg, and this angle is theta. Component of mg along OB is mg cos theta, and this is equal to tension T2. So T2 will be mg cos theta. This is minimum tension, and condition is given T1 is 2T2. So mg plus mv square by L is equal to 2 mg cos theta. Equation number 1. Kinetic energy at A converts in potential energy at B. Height of B with respect to A. Is C point AC. Height H is this height H. H is equal to AC, and AC is L minus L cos theta, or L 1 minus cos theta. Kinetic energy at A, KE at A is equal to half mv square, and potential energy at B is mgh, or mg L 1 minus cos theta, and this KE and PE will be equal. 1 upon 2 mv square will be equal to mgl 1 minus cos theta, or mv square by L will be 2 mg 1 minus cos theta. इक्वेशन नंबर 2। इक्वेशन नंबर 2 से mv² बाई एल की वैल्यू इक्वेशन नंबर 1 में पुट कर दी, तो mg प्लस 2mg 1 माइनस कोस थीटा विल बी इक्वल टू 2mg कोस थीटा। mg से डिवाइड कर दिया तो 1/2 1 माइनस कोस थीटा will be equal to 2 cos theta. 1 plus 2 minus 2 cos theta is equal to 2 cos theta. 2 cos theta plus 2 cos theta is equal to 3. 4 cos theta is equal to 3. Cos theta is 3 by 4. Theta is equal to cos inverse 3 by 4. The maximum angular displacement will be cos inverse 3 by 4.